Writing async code on the server is all about freeing up threads as soon as possible so they can be used for other tasks. This improves the scalability of your application. And this is important to know. Writing async code is for scalability improvements, not for performance improvements per se, although it often has a positive effect on performance as well. Freeing a thread can be done when an I/O operation happens, and reading from a database, that's an I/O operation. Let's say a synchronous request comes into our API. To handle that request, ASP.NET Core requires a thread from the thread pool. The work that eventually has to be done in our case is a call into our database, an I/O call. And as we're working synchronously, the call will be blocked until the I/O call is finished. It's thus not available to handle other requests. In a synchronous case, one thread is used to fully handle one specific request. When a second request or a third request comes in, it thus requires another thread from the thread pool to handle the request. Now, imagine there's only 2 threads available on the thread pool. This third request has to wait for the thread to become available. It's only when one of the first 2 requests is finished that an additional request can potentially use the thread previously used for another request. At this moment, the client calling the API is already experiencing a slowdown, and if it takes too long for a thread to be freed up to handle the request, the client will be met with an error, typically a 503 service unavailable. And that's not what we want. Also, while the I/O call is going on, those 2 threads are just sitting there waiting for the call to complete. They're not really doing any work. Now let's see how that works for an asynchronous request. An async request comes into our API. To handle the request, ASP.NET Core still requires a thread from the thread pool. The work that has to be done, again, contains a call into the database. But this time that part of the call is handled asynchronously. Instead of blocking the thread is returned to the thread pool. It's only when the I/O call is finished that a thread is required to handle the rest of the request. But in the meantime, the thread that's been returned to the thread pool can be used by other requests. So if the second and third requests come in, they can be handled without any issues. When working asynchronously, one request can be handled by different threads, and one thread can handle different requests. In other words, supporting async for our API improves scalability because it allows the API to use the server's resources, translating into threads, in a more efficient way than when we would just build it synchronously. So we're going to write and use async methods. Let's continue with our repository pattern implementation.